All right, today we're going to talk about a brand new AI that solves a problem I know you've experienced. We're talking about a tool that can listen to any audio file and tell you the exact start and end time of every single word, right down to the millisecond.
You know that feeling, right? You're deep into a movie, totally absorbed, and then the subtitles are either a second ahead or lagging way behind the actors. It just shatters the illusion, completely pulls you out of the moment. So frustrating.
And it's not just movies. Think about trying to edit a podcast, endlessly scrubbing back and forth just to find one little word. Or that karaoke night where the lyrics are just a disaster. This timing problem is everywhere, and it's a huge headache. But what if we could finally fix it for good?
So how in the world does this work? Let's pull back the curtain and look at the technology that makes this kind of perfect timing even possible. It's a really cool AI technique that basically acts like a GPS for words.
Okay, so the official name is forced alignment. And that audio GPS analogy, it's honestly perfect. You give the AI the audio file, that's the map. And then you give it the transcript. Those are all the addresses you want to find. The AI then cleverly breaks down both the sound and the text into their most basic speech sounds, finds the absolute best way to match them up, and then drops a pin on the exact location of every single word. It's not guessing, it's pure, precise calculation.
And here's the best part. It's incredibly simple to use. You just start with your sound file, you feed it the text that's spoken in that file, and then the AI does all the heavy lifting. What you get back is this beautiful, clean list of every word, each one with its own super precise start and end time.
Now, this kind of tech has been around for a bit, but a new model just dropped that takes this whole thing to a completely different level. So let's meet the star of the show.
Say hello to the Quan 3 Forced Aligner. It's part of a bigger family of AI audio models, but this one is a specialist. It was built for one critical task, finding the exact timing of words with what is honestly jaw-dropping accuracy.
And what makes this tool a real game changer is just how accessible it is. We're talking about a small model, which means you don't need some massive supercomputer to run it. You can even get it working on a regular CPU. Plus, it supports 11 different languages. And maybe best of all, it's open source. That means anyone can use it, tinker with it, and build amazing new things on top of it.
Okay, that all sounds fantastic on paper. But you know what they say? Talk is cheap. So let's stop talking about it and actually see what happens when we put this model to work.
All right, here's the first bit of text from our sample audio file. Let's say we're trying to find the exact location of just one word, fleeting. Can the AI really pinpoint it for us?
And boom, just like that. The model comes back and tells us the word fleeting was spoken between 5.12 and 5.68 seconds into the audio. That is ridiculously precise. It's not just in the right neighborhood, it's standing right on the doorstep.
That was impressive. Let's try it again. Here's a different phrase from that same clip. This time, our target is the word warm. Let's see if it can do it again. Yep, nailed it. Again. It finds warm starting at exactly 8.35 seconds and ending at 8.71. This level of precision is exactly what's been missing from so many of the tools we use every day. So that demo is pretty convincing, right? But how does it really stack up against other tools out there? It's time to get into the hard data. This is the moment of truth.
So in this corner, we've got our new challenger, the Quan 3 Forced Aligner, and in the other corner, we have some of the established open-source champs, like WhisperX and another model called NFA. So how do we keep score?
Well, the metric we use is called Average Absolute Shift, or AAS. It's a really simple idea. It just measures the average timing error. Basically, how far off is the AI's timestamp from the actual human-verified time. So for this number, lower isn't just better. Lower is everything.
And the results are, well, they're kind of shocking. It's not even a close fight. Just look at this chart. WhisperX has an average error of over 133 milliseconds. NFA is a little better, around 130. But get this, the QN3 model's average error is just 42.9 milliseconds. That is a gigantic leap forward in accuracy. The reason why is its modern AI architecture. It was trained specifically for this one task, letting it understand speech timing way better than older models. It's playing in a completely different league.
So, okay, it's faster, it's easier to use, and it's way, way more accurate. But so what? What does that actually mean for us? Why is this such a big deal?
It means that all those little frustrations we talked about at the start,
they could become a thing of the past. We're talking about subtitles that are always flawlessly in sync, podcast editing tools where you can just edit the text and the audio magically follows, karaoke apps that never miss a beat, language learning tools that can highlight every single word in real time as it's spoken. The creative potential here is just massive.
So if you remember one thing from this, let it be this number, 3. This technology is 3 times more accurate than the leading open source tools that came before it. And that's not just a number on a chart. That's the difference between subtitles that feel almost right and subtitles that feel so perfect you don't even notice they're there. A jump like that doesn't happen very often.
And that brings us to the final, really exciting question. We've just been handed a new kind of superpower, the ability to know the precise location of any word, anywhere in a sound file. So the question isn't just about fixing old problems anymore. The real question is, what entirely new things are we going to create?